Hello everyone. My topic for today is Carbine and altruistic scheduling mechanism in multi-resource clusters. The paper was authored by Robert Crandall, Mosharaf Chaudhry, Aditya Akela, and Ganesh Anantanarayanan. My name is Josh Parekh. With the introduction of services like AWS, multi-resource clusters or clusters with multiple resources uh, has increased a lot. Uh, these clusters, the resources on these clusters are managed by resource managers, which are responsible for scheduling these resources and providing performance isolation between different users and groups. These clusters or the resource managers on these clusters are responsible for managing jobs with complex DAGs and also allow job specific constraints. Modern schedulers usually provide performance isolation between different users and group and also provide instantaneous fairness. This fairness is based on a short-term scheduling and often overlooks the benefits that can be achieved by having a long-term approach to scheduling. The authors plan to mitigate this problem by proposing an long-term altruistic approach called as Carbine. Carbine basically states that uh, every resource at a given point has some resource that is of no use or is currently not used and can be relinquished or yielded and can be yielded at that point without affecting its own execution. These resources can be reallocated to jobs and can be utilized in a much better manner. This approach can be implemented by including a local altruistic resource management module uh, in each application that runs on the cluster, and it is the responsibility of this particular module to determine how much resource can be yielded, by each application. The global cluster scheduler then reschedules these resources to other jobs that can better utilize these resources. Better utilize these kind of resources. Uh, so the setup is very useful in a cluster of data analytics where there are multiple jobs running at the same time, and these jobs have complex DAGs and have to be and such a job that run by multiple users at the same time on the cluster. On the cluster. Uh, in data analytics cluster, jobs usually arrive at a similar time and are put into queue by an interjob scheduler, and which passes these jobs to the interjob scheduler. The interjob scheduler, schedules resources for these jobs. The main objective of Carbine in this process is not just to ensure performance isolation, but also to be competitive with best approaches for the secondary matrix. For the secondary matrix. To quantify this, the authors ran a workload consisting of DPC-DS queries on 100 machine clusters in a Chameleon and pick state-of-the-art approaches with respect to each matrix and evaluate them on three dimensions on Jane's Fair Index. Jane's Fair Index is computed on 1 minute interval for fairness, average job completion time, and for performance and make span for cluster efficiency. So Jane's Fair Index basically is a three matrix index where different schedulers are where different schedulers are measured for their performance on these three indexes, which is interjob fairness, job performance, and cluster efficiency. The three schedulers that the authors used for testing are dominant resource fairness, shortest job first, and Tetris. All these schedulers were implemented in Apache Yarn and were tested on Jane's Fair Index. The result of each the result of these three schedulers on Jane's Fair Index is as follows. Tetris for interjob fairness. For interjob fairness, sorry, each of these clusters outperformed its counterpart only in a preferred matrix and significantly underperformed in secondary matrix. If you look at the results of each of the three matrix, then one particular scheduler in each of these metrics performs significantly well and significantly well than the other two. For example, DRF is the best for fairness, interjob fairness, but worse than Tetris and shortest job first in terms of job performance. SJF for shortest job first is worse than Tetris and DRF in terms of cluster efficiency and interjob fairness, but Tetris improves the cluster efficiency the most. Carbine was later implemented and tested on a similar environment, and its results were measured with the three schedulers we tested before. If we look at the diagram here, it shows that Carbine challenges each of the leaders in these three matrix. Like for interjob fairness, Carbine is almost challenging DRF, and for job performance, it is almost similar to almost similar to shortest job first, and the same thing for cluster efficiency, where it is almost similar to what Tetris is. So what it says is Carbine almost achieves similar fairness with DRF, a comparable average job completion time with shortest job first, and comparable cluster efficiency with Tetris. While Carbine can be unfair on small time intervals due to leftover allocations, on longer time intervals it is closest to DRF because of its long-term approach towards fairness. Carbine is slightly worse in terms of job performance than shortest job first because it does not attempt to delay any job beyond its fair share calculated completion time, and slightly worse than Tetris in terms of cluster efficiency. Because it looks for packing only tasks from altruistic jobs instead of treating all runnable tasks equally. To conclude, the test conducted by the authors proved that although the job completion times do not change on short run, taking a long-term altruistic approach significantly improves application level performance and cluster utilization while providing the same level of performance isolation as modern schedulers. Deployments and large-scale simulation on benchmark and production traces show that Carbine closely approximates DRF in terms of performance isolation while providing 1.26 times better efficiency and 1.59 times better lower average completion time. Thank you.